Okay, let's start. Vihan, Joshua, Sampriti, Iha. So last class we were doing thermo in this. Let's proceed further in that discussion. Check, we have reached up to this part. Thermodynamic processes, right?
Yes.
Okay. So normally this 9 o'clock class, you please take 9, 5, 9, 10 because earlier class is also ending at 9. Sometimes it get extended to 5, 10 minutes, right? तो आप कहीं जाना मत, ऐसा नहीं कि क्लास होगी 5-7 मिनट आगे पीछे होगी बिकॉज वो क्लास एंड होगी देन दिस क्लास विल स्टार्ट. ओके, सो वो एग्जैक्टली सेम टाइम पे नहीं स्टार्ट हो पाता कई बार बिकॉज somewhere we are in the middle of some things we complete it first and then move on. Okay, so let's start. Thermodynamic processes remaining, I think you have revised and come for today's class. Okay, whatever you've done in the last case में. चलिए thermodynamic processes पे बात करते हैं. So isothermal, isochoric, isobaric, adiabatic, then there are terms like isenthalpic, isentropic, polytropic. Now, what is meaning of isothermal? Isothermal name itself clearly tells you that T is constant. Okay. How many of you recall reversible versus irreversible in the last class? Have we discussed that or not? अभी तक हुआ discussion? अभी नहीं हुआ. Okay. So let's quickly write down one heading. Reversible versus irreversible. Then I come to this discussion. Okay. Otherwise, you will not be able to understand this. अब रिवर्सिबल प्रोसेस को ध्यान से समझ लो पहले एक बार. So think about a piston cylinder arrangement like this. Okay. So there's a known amount of gas, volume, moles, temperature. Everything is same. External pressure is same. Let's say atmospheric pressure. Here also atmospheric pressure. Piston, cylinder, exactly same size. Everything is same. What we're trying to do is we are trying to put mass capital M in both the situation somewhere here. But the difference is, in this case, I'm taking small sand particle, each of mass dm, whose integral is capital M. And here I'm taking small m masses, each added up to capital M. Okay. So you can think of, यहाँ पे sand particles है, छोटे छोटे particles है, जितने भी छोटे सोच सकते हो आप. और यहाँ पे कुछ pieces है. But दोनों तरफ mass कितना है? M. Now, case 1, if I put a small particle here, can I say this piston will move a small distance dx down? Right? Piston पे क्या mass रखा आपने? dm mass. So a force dmg will be applicable downward. Right? Because of this dmg, this piston will displace by dx distance. Because of that, inside pressure will rise up with some small dp. Volume will reduce with some small dv. Okay? So don't you think that all the changes are differential changes or very small changes? Is it clear? It's moving gradually down on the left-hand side. Is it okay or not? So first dm, second dm, third dm, fourth dm, fifth dm. And as you know, that dm mass, if I keep on putting, maybe it takes years and years, right? काफी सारा टाइम लग सकता है, तो 10 साल लग गए आपको ये करने में, पार्टिकल रख रहे हैं, तब तक बाकी लोग बीटेक करके आ गए, जॉब करने लगे। तो पॉइंट इज, left side process is very slow process, and this process is called quasi static. Quasi static. Quasi static means almost static, almost non-moving, or it is also called infinitesimally slow. इतना स्लो, इतना स्लो, इतना स्लो कि बहुत स्लो, right? Quasi static, infinitesimally slow process. This is a reversible process. This is ideal, but not feasible in reality. In nature, you can't get such process. No process are like that. So are you understanding the reference frame? The reference is reversible means what? Is it clear? So at every moment, the forces are balanced. DMG downward लगेगा, DP की वजह से extra force, DF ऊपर जाएगा. These will be balanced. Exchange of temperature across the piston will be very smooth. And there is no heat loss at any point of time. And there is no kinetic energy in the piston. Understanding? So there is no heat loss or there is no loss of energy as such. It's a very gradual process. And if I remove DM mass, DM mass, DM mass, DM mass, DM mass, I will be able to reach to the same point back. Are you understanding? Why we are reaching same point back? Because there is no loss of energy in this whole process. Is it okay? So what is this process called? Left side one. Reversible. Reversible should not be confused with cyclic. It's not cyclic कि एक ring complete होना चाहिए, एक loop complete होना चाहिए. No. Cyclic is different thing. Reversible means you may go forward, but still the process is reversible. So what is the important thing about reversible? You'll say three things. Quasi-static, infinitesimally slow, and whenever you write expression of reversible, you have to use differential word dp, dt, dv, ds, du, dg, dq. Understand? We have to use all differential terms when I'm talking about reversible process. Okay? कर लेंगे. Now, coming to the next part. Coming to the next part, the right-hand side of the story. I'm putting the same mass capital M, but this time the approach is different. I'm putting M mass. So let's say I'm putting the first M. Piston was here. It moves like this. Next M moves like this. Next M moves like this. See here. See the movement, everyone. Okay. There'll be significant drop, right? And for this kind of sudden drop, because you put M mass, not sand particle, so sudden change will be there. In that case, heat losses will be there, energy losses will be there, forces will not be balanced. Okay. And I will not be able to reach to the same position when I remove the cause. If I remove the cause, I will not get the same effect. Is it okay? I'll not go to the same position. So if you understand this, please confirm. Joshua, Sampriti, is it clear? Vihan, is it clear? Iha, is it clear? चलिए, अगर समझ में आ गया तो लेफ्ट वाला है रिवर्सिबल एंड राइट वाला कौन सा हुआ? इरिवर्सिबल. ये है इरिवर्सिबल. अब थोड़ा सा इसकी डेफिनेशन पे बात कर लेते हैं, आपको अब समझ में आएगा सब कुछ. So write down reversible process. The process that can be reversed by a very small change is known as reversible process. The process is carried out in such a manner so that the system is always in thermodynamic equilibrium at every stage of process. हर moment में equilibrium में हो. Every moment forces are balanced. Every moment thermal equilibrium is there. Every moment chemical equilibrium is there. Every moment mechanical equilibrium is there. The process is carried out in such a way that the difference in driving force and opposing force is infinitesimally small, so that process takes place at infinitesimally slow rate. Is the line clear? The force which is driving and the opposing force is very, very small differentiated, right? So that the process is happening very slow. Okay. Net df is almost zero. Make sense? Vihan, is it clear?
Yes, sir.
Okay. So this is your point number one. Any problems in this? इसको नोट करिएगा प्लीज सारे पॉइंट्स, डायग्राम्स वगैरह बना के प्रॉपर्ली.
So I think I have this noted down.
Okay. Any doubt in this part? Any issues you can please ask. Now look at irreversible. Can I go to irreversible now? Yeah. Writing. Okay. For so reversible is ideal reversible process will take how much time? As I said, infinite time. Practically not possible, right? Infinitesimally slow. Strictly speaking, there is no ideal reversible in universe. I think already you know these points. Just note down quickly.
Sir, in this process, basically, as the piston is moving down, since it's so small, there's no heat loss or energy loss, right?
Yeah, we can say there's no losses. There's no loss of energy. There's no sudden change in energy. No, it's a very gradual process. So when the piston is moving slow, can I say forces are all balanced almost? And that dx moment shows that the force which is bringing it down is df, which is very small. Then comes thermal equilibrium. Changes in temperature will be of the level of dt. Okay. Then comes the chemical equilibrium. So there is no concentration gradient also observed. So it's all balanced kind of thing, right? Whereas in this case, it is not like the same. In this case, it will be sudden changes, right? So changes in the other case will be delta x.
So basically, in reversible, we can say that if there is like the change in energy is basically negligible or tends to zero.
Yeah, or we can say if you want to reverse the cause, you will reach to the same position where you started off in reversible, which is not true for irreversible. कर लेंगे.
Sir, have we done thermodynamic equilibrium in like chemical equilibrium?
Thermodynamic equilibrium.
Thermal equilibrium.
Yeah, yeah, yeah. Okay. Anyway, it will come here also again, no worry. Now, next is, so reversible process I've explained already. Now, just write the irreversible definition. Irreversible is if during the process there's a finite difference in driving force and opposing force. Okay. This will get completed in finite time. At intermediate stage of irreversible process, different state function are not defined. बीच की स्टेट में बात नहीं करेंगे, सिर्फ एंड पे बात करेंगे, राइट? All real processes are irreversible. Okay. So irreversible वर्ड भी समझ में आना चाहिए. कोई डाउट है तो पूछ लो यहाँ पे, कोई भी स्टेटमेंट यहाँ पे आपको कोई दिक्कत हो. Otherwise, please note down these statements. अरे आद्विक जी कहाँ रह गए आप?
अरे सर, मैंने उस समय जो फिजिक्स सर से उन्होंने पूछा था कि 9 बजे ज्वाइन करना, उन्हें मना कर दिया था उस समय। मैंने बोला ठीक है सर।
क्यों? आपको मैंने लिख के दिया था आज तो।
हाँ हाँ, अभी मैं वो मैसेज देखा। हाँ हाँ हाँ।
No, today only in notebook I wrote no, like what time your classes will be there, 9
या
to 10.
या
Then why
या
you got confused?
बोले कि अभी 9 से 10 वहाँ पर भी फिजिक्स क्लास भी रहेगी। तो मैंने उनसे पूछा उस समय, उन्होंने नहीं नहीं नहीं, आज ज्वाइन करने की जरूरत नहीं। मैंने बोला ठीक है सर।
नहीं तो फिजिक्स थी क्या 9 से 10 आज?
बोल तो रहे थे वो कि एसएचएम करवा रहे हैं, तो उसके हिसाब से ज्वाइन करने के हिसाब से।
भाई कंफ्यूज हो गए फिर उसमें।
हाँ
आज
हाँ।
नहीं होती सर की क्लास, ट्यूसडे नहीं होती, दैट इज ऑन अदर डेज ओनली। ओके।
नहीं, क्योंकि उन्होंने बोला कि आज की ज्वाइन करने की जरूरत नहीं, उन्होंने बोला था।
You
हाँ।
please follow what we have discussed.
या
Don't
या
take
या
it. Okay. So we are somewhere discussing about reversible and irreversible process. You know reversible process?
या रिवर्सिबल आई नो सर।
What is reversible?
रिवर्सिबल में इट्स लाइक ऑल अबाउट वेरी वेरी स्मॉल, इन्फिनिटेसिमली स्मॉल चेंजेस होते रहते हैं उसमें, विच इज लाइक अननोटिसेबल।
So
सो
basically,
वीडियो आई एम ऑन फोन सर।
quasi-static, infinitesimally slow,
या
ideal
स्टैटिक
but not
इनफाइनाइट।
feasible in reality. Okay.
आपने वो क्लास में
And
पढ़ाया था
all the
कभी?
values will be dp, dt, dv, ds, du, dg, and dq. Okay. All these terms will be with a differential term. Okay, Advik?
या
And on the other side, if it is irreversible, there will be sudden changes. Okay. So the key difference is the process is carried out in such a way that the difference in driving force and opposing forces infinitesimally small, so that the process take place at infinitesimally slow rate. That's a reversible. Irreversible is when the difference is more. Okay.
या
ठीक है, चलिए। सो अब आगे बढ़
बस
जाए।
इतना ही था। हाँ सर, हाँ सर।
ठीक है। और लेट्स टॉक अबाउट processes now. Write down isothermal, isochoric, isobaric, adiabatic, isenthalpic, isentropic, polytropic.
Sir, I just had a question in irreversible. Intermediate stages means during the process, right?
Yes, yes. So let's say you have 1 and you have 3. So 1 to 2 you are going now. In between 1 to 2, what is happening? You can't define PV, right? We talk about only PV on the endpoints. So isothermal means what? T
कांस्टेंट
constant.
टेम्परेचर।
Choric means V constant. Baric means
हाँ।
P constant. Adiabatic means Q is constant. There's no heat exchange with surrounding. Okay. Q exchange with surrounding is 0. And isenthalpic means delta H is 0.
एंट्रोपी
Isentropic is
डेल्टा एच इज एंट्रोपी ना सर?
entropy is delta S. That is
ओके।
isentropic.
हाँ हाँ, ओके
And
फाइन।
polytropic is PV power X is constant. So these are different processes. Any difficult in this?
नो सर, नो सर, ये आई डन टिल हियर। इससे आगे कभी होगा?
ठीक है.
हाँ,
So
एक मिनट।
whenever it is reversible, आप use करोगे dt. And whenever it is irreversible, you'll use delta D. Whenever it is reversible, you'll use dV. Here, irreversible, delta V. dP and delta P.
ठीक है सर।
Okay. And adiabatic also dQ and Q.
क्यों?
Delta Q, you can say. Is it okay?
Yes sir,
Any
1 minute,
difficult?
I'll copy it down so some things.
Yes. फिजिक्स समझ में आई आद्विक?
हाँ सर, आ गई सर।
वेरी गुड. एंजॉय कर रहे हो क्लासेस अब? हाँ.
हाँ सर, हाँ सर, हाँ सर।
नहीं, हंस हंस रहे तो मतलब मजा नहीं आ रहा है?
आ रहे सर, आ रहा है सर।
आ रहा है? ज्यादा ही
हाँ।
आगे लग रहा है. थोड़ा ज्यादा हो रहा है. 3 घंटे कल हो गया, 2-3 घंटे आज हो गया. सर ने कितने बजे छोड़ा आज?
तो सर 7 बजे ना, 5 से 7,
हाँ.
2 ऐसा, हाँ।
ओके. चलो आगे चले.
1 मिनट सर, 1 मिनट। पॉलीट्रॉपिक। सर पॉलीट्रॉपिक आप एक्सप्लेन कर सकते हो सही बार?
हाँ, PV power X is constant. We'll talk about it in detail. Don't worry.
ओके फाइन सर,
Just
फाइन।
like PV power X is constant. Now, so reversible is clear, irreversible is fine, and we understand different process name at least. Now, there are some terms that you should know. Write down modes of energy exchange.
Hmm.
It can be with heat or with work.
वर्क, या
These are forms of energy.
Okay, so 1 minute.
Heat and work. Vihan, is it clear? Joshua, how will you define heat? Heat क्या है?
Sir, heat is just heat. Wait.
Heat is just heat. क्या बात है? ये हुई ना definition. Sampriti, what is work? Work is just work. Work is worship. यही तो बोलते हैं. कर्म ही पूजा है और पूजा ही कर्म है. ये मत लिखिए आना प्लीज. Heat is when the energy transfer takes place because of temperature difference between system and surrounding. It is known as heat. Okay. Energy transfer between system and surrounding due to difference in temperature. Okay. That is called heat. That flow is called heat basically, right? Heat flow हो गया. It will be from cold to hot or hot to cold.
Hot to cold.
Hot to cold.
Hot to cold.
Okay. And on the same line, there is something called zeroth law of thermodynamics, which is when A and B are in thermal equilibrium and B and C are in thermal equilibrium, then A and C are also in thermal equilibrium. बेसिकली ए और बी का टेम्परेचर अगर आपने मेंटेन कर दिया, बी और सी का मेंटेन कर दिया, तो ए और सी का भी सेम लेवल पे मेंटेन होगा, राइट? ओके, सो हीट इज energy transfer taking place because of temperature difference between system and surrounding is known as heat. What is work? Energy transfer which is not heat or which is not because of temperature difference is called work. बहुत बेसिक डेफिनेशन हो गई. टेम्परेचर डिफरेंस की वजह से जो कुछ हो रहा है उसको आप हीट बोल दो. उसके अलावा जितना भी कुछ है वो सब क्या हो जाएगा? दैट्स ऑल इज वर्क. So work, you must have heard of work can be PV work. Okay, PV work is defined as dW is minus PdV, or W is minus P external V2 minus V1, or minus P external V final minus V initial. ये सब फॉर्मूले होते हैं. ये रिवर्सिबल में यूज होगा, ये इरिवर्सिबल में यूज कर सकते. Okay, any problem in this? So work can be PV, work can be non-PV also. There can be non-PV work as well. आगे चले. So work can be of many type: mechanical, electrical, magnetic, gravitational, etc., 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 right? So same energy transfer can be called work or can also be called heat depending on the choice of system. But I hope type of work you can understand. For example, you have a cell, okay, galvanic cell. उस पे कहाँ पे PV लगाओगे? There's no P into delta V, no? There's no piston cylinder arrangement. So there's no PV work done. What work done is there? Electrical work done is there, right? So work can be of different type. चलिए अभी थोड़ा सा काम करते हैं साइन को लेके. सो राइट डाउन, एज पर केमिस्ट्री, heat given to system is positive, and as per physics, heat given to system is positive. ये तो दोनों में ही सेम ही है. फाइन. वर्क डन ऑन द सिस्टम इज पॉजिटिव एंड वर्क डन बाय द सिस्टम इज नेगेटिव. ये केमिस्ट्री का डिस्कशन हो रहा है. ये जितना कुछ भी लिखा है सब केमिस्ट्री के लिए IUPAC कन्वेंशन है. नोट डाउन. So if you're giving heat to the system, positive. If system is releasing heat, negative. If you're doing work on the system, positive. If system is doing work, negative. Okay. So please note down this portion. Physics वाला छोड़ दो आप, इतना लिखो पहले. So what is our equation? Our equation is like a balance sheet between delta U and Q and W. So you can say delta U is Q plus W. All right. What is this law called? Can we say innovator's first law? of thermodynamics? Yes, please. Is it clear? Delta U is Q plus W. Is in a way first law of thermodynamics. Q, heat given, heat supplied. W, work done on the system. Delta U, positive. It's like balance sheet. Okay. So delta U is change in internal energy. Q is heat and W is work done. Raise your hand if it is clear up to this, everyone. Any doubts you can please ask. No doubts?
And what's the statement for first law?
Yeah, I'm coming to that. Energy of total universe is always conserved. Total energy of an isolated system is always conserved. Absolute value of E cannot be calculated, but the change in E can be calculated for a particular process. That is law of energy conservation. Right now. Law of energy conservation. Okay. Shall we proceed? So mathematical form of first law is delta U is Q plus W. No. Delta U is Q plus W. Now come back. So what all we have done so far? System, hypothetical boundaries भी हो सकती हैं, surrounding, outside system, variable PV, NT, W, delta H, delta U, delta S, Q, delta E, delta G, state function, okay, path function, extensive, intensive. If there's a system, heat supplied to system positive, heat coming out as negative, okay. All these things we are aware about. Let's say there's a system where is no work done. If there's no work done, can we say Q1, Q2, Q3 आपने दिया, Q4 बाहर चला गया, right? So can we write Q1 plus Q2 plus Q3 is equal to Q4 in a way, mathematically? Okay, there is no change in internal energy in that case. Same thing, if there is internal energy change, you can always write that. So for example, this case, Q1, Q2, Q3 is given, Q4 is out, but internal energy is increased by delta U. So we can say delta U is what? How much you have given and how much has come out. Yes or no? Mathematically, can you tell me what is the equation? Advik? Q1, Q2, Q3, Q4 is out, delta U is the change. What's the value?
So Q1 plus Q2 plus Q3 is equal to Q4.
And
Is
delta U,
equal to minus of Q4, no?
Q1 plus Q2 plus Q3 minus Q4 is
Is 0.
delta U. Delta U, that's right.
Delta U. But
This,
then
this time delta U. If it is increasing by delta U, then in that case, I'm saying.
Okay, then it's delta U.
Last case was 0 because last case was no delta U, right?
Yeah.
Now, the same thing is work. Now, let's say work is also involved. System has done some work, right? So what will be the value? Q1 plus Q2 plus Q3 minus Q4 minus W is delta U. Okay. So eventually, what is our final equation which comes out is this equation. Delta U is Q plus W. Okay. We can write delta U is Q plus W. Note down, please. Case by case शुरू करते discussion. So these are your initial cases. Already you've written these names. So let's write on the heading isothermal reversible expansion. Isothermal reversible expansion. वहां से शुरू करते हैं. And gradually we'll see other cases. लिखिए isothermal reversible expansion or reversible isothermal expansion. So if it is isothermal, can I say dt is 0? Temperature constant and dt 0 हो जाएंगे. What is NCV dt? NCV/dt. So first try to understand what is this word C. लिख लीजिए इसके बारे में. C is defined as heat capacity, okay, which is equal to N times small c. And what is small c? Small c is called molar heat capacity. And N is number of moles. Understand? It's like C is per mole. If you multiply with 2 moles, it will become NC, and that NC is capital C. Is that okay? So when you write Q or heat, dQ over dt is known as C, or heat capacity, or we can say dQ is heat capacity into dt. Basically, definition of heat capacity is what? For the given substance, how much amount of heat is required to increase the temperature by 1 degree Celsius. So dt into C is how much? dQ. So can I say dQ upon dt is C? Any problem in this part? All right. Now remember, when the same dQ upon dt C is written, this C can be N times small c, and this N times small c can be NCP or NCV, where respectively these are molar heat capacity at constant pressure, and the CV is molar heat capacity at constant volume. कर लेंगे? And the same Cp minus Cv comes out as R for ideal gas. The same Cp minus Cv is R for ideal gas. Is it okay? Now learn one or two terms here. NCDT is Q. NCPDT, or we can say dQ. NCPDT is dH. NCVDT is du. तीन टर्म्स बोलना मैं आपको. NCDT, NCPDT, and NCVDT. NCDT is heat capacity. N is number of moles, multiply kiya, dt multiply kiya, you get the heat. NCPDT will give you enthalpy, because enthalpy change at constant pressure is dH. H basically, that is CPDT. And at constant volume, work done will be 0. So du itself will be the heat given. Is that okay? Because du is dq plus dw. dw तो 0 हो गया constant volume पे. So du ही dq हो जाएगा. If du ही dq, so du में बोल सकता हूँ NCVDT. Can I also write that du is वो वाला dq जो constant volume पे, and dh is the dq which is at constant pressure. Does it make sense to you? Everybody, are you understanding these terms? What I'm trying to convey here is NCDT is dq. First line is clear, raise your hand if it's clear. First point is clear. Advik. Second is NCPDT is dH, or we can say dq at constant pressure. CP dqp, CV dqv. What is dqp? इसी को dH बोलते हैं. That is enthalpy change at constant pressure. And what is dqv? That is enthalpy change at constant volume or internal energy. I hope that makes sense of the whole discussion. Now, come back to our current discussion. ये सब मैं साइड में रख देता हूँ थोड़ी देर के लिए. Let's keep it here. इसको इधर रख दो. ठीक है? Now, how many understand dt is 0, so NCVDT is 0? When dt is 0, the NCVDT is 0 होगा. What is NCVDT called? du. What is du called, everyone? Change in internal energy.
Internal energy.
Okay. Or we can say enthalpy change at constant volume is 0. So du is how much? Du is dq plus dw. That we know. That's the basic definition of first law. Balance sheet is how much q, how much w. dq plus dw is du. Okay. So in chemistry, if you're talking about compression, that means you're pushing the piston down. That means you're doing work on the system. Those works are positive. PdV form में value आएगी. And expansions are minus PD. Okay. Expansions will be negative, compressions will be positive. Basically, आप ऐसे समझो dW is minus PdV. अगर expansion होगा, so dV positive होगा, तो term negative हो जाएगा. यहाँ भी फॉर्मूला माइनस PdV लिख लो, बट अगर dV नेगेटिव होगा तो टर्म पॉजिटिव हो जाएगा. आई होप यू अंडरस्टैंड दिस पॉइंट. Any problem with this? Okay, now which case are we talking about right now? Sampriti, which case we are talking about right now? Reversible isothermal. So isothermal, you got dt 0, NCV dt 0, du 0. If du is 0, can we say dq plus dw is 0? Because du is dq plus dw. So can we say dq is minus dw? लिखिए यहाँ तक पहुंचिए. Then write dw is minus pdv. What is dw? It is minus pdv. If it is an ideal gas, what is p? nRT by v. Values रख दो. dw is equal to minus nRT upon vdv. इंटीग्रेट कर दीजिए. v1 to v2 लिमिट हो गई. लिमिट्स आपको पता है. इनिशियल लिमिट, फाइनल लिमिट, राइट? Advik, what is dv upon v integration?
Sir,
dv upon v integration is?
so natural log of v2 by v1.
Very good. ln v or ln v, okay? And
Yes,
this
sir.
limits v1 to v2, it will be
v2 to
ln
v1.
v2 by v1.
Yeah.
Okay. So can you reach to this result? W is minus nRT ln v2 by v1. Can you reach up to this result, everyone? And can we say this is equal to minus q also? Because W is minus q. Why W is minus q? यहाँ पे क्या आप कर लेंगे. चलिए तो इस पे एक तो क्वेश्चन सॉल्व करते हैं, फिर ग्रेजुअली बढ़ेंगे आगे, वन बाय वन आराम आराम से क्वेश्चन सॉल्व करते हुए आगे बढ़ते हैं. सो लेट्स ट्राई सम क्वेश्चन ऑन दिस पार्ट. जस्ट गिव मी अ मिनट. Yes. So I hope this part is clear, everyone. Q is clear. W is clear for this. Any doubts? If you want to convert ln v2 by v1 into log at the base 10 v2 by v1, what term will be multiplied? 2.303, which is log of 10 at the base e. I hope this maths is clear. Log x at the base e is log x at the base 10 to log 10 at the base e. Log 10 at the base is 2.303. That comes as multiplication. Let's try this question. Correct. At 300 Kelvin, reversible isothermal expansion, 1 mole of ideal gas is undergoing reversible isothermal expansion from 1 liter to 10 liter. Find out the value of Q. Value of R is given as 8.31 joules per mole per Kelvin. Try to answer this question. What's the answer?
So is it 5741.3, 0.379?
Okay, can you tell me in terms of R? It will be minus 1 R 300 2.303.
2.303.
That's all.
That's all.
Log of 10 by 1 is 1, right?
Yeah.
Very good. So if we solve, you can get the result out of it. कर लेंगे सभी. Advik, is it clear? Yeah, is it clear? Sampriti, Joshua,
Yes, sir.
is that okay? Vihan? Chali. So this is the value of Q. Work done निकाल लोगे? Work done will be minus of that Q. Now come to other side of story. Other side of story is irreversible expansion. So if it is irreversible expansion, how much is delta D? Write down delta D is 0. इसको मैं एक बार दूसरी जगह से दिखा देता हूँ. Just give me a minute. So let's name it. I hope the first part is clear. Any problem with this? Answer this question, please. Q, W, delta U, and delta H for this question. This time, it is isothermal expansion from 10 atmosphere to 1 atmosphere. Try. First, solve this question, then I'll come to the next phase. Please write down the question and try to solve. What all formulas we know so far? We know just one formula. Q is nRT ln V2 by 1, which is minus W. उसी को use करना होगा, of course. So can you give me the answer quickly? So अभी लोग एक ही formula किया अभी तक, तो एक ही चीज पूछूंगा मैं अभी. Try to answer.
Sir,
Yes.
R की value I can take as 2 calorie per mole
No,
Kelvin.
just I need answer in terms of R. Keep it in terms of R. It's okay.
Yeah, so then the answer is 6.909 R. वो का क्या रहेगा सर? Joules.
6.909
R joules.
R joules. Yes, 690.9 R.
690.
Wait. Yes, 690 my bad.
So I
With
got that
minus
as
sign.
well.
Yeah.
Hmm.
Are you getting this answer, everyone? Please check.
Yes, sir.
Yes, sir.
सबका आ रहा है? कोई doubt? Sampriti done?
So del H and del U will be 0.
Yeah. The next part is delta U and delta H. What are these values? So remember, there is a basic thermodynamic relation which is H is U plus PV. Note down. H is U plus PV. and dH is d of u plus PV. Okay. So dH is du plus d of PV. Now du is 0 because isothermal, and dt is 0. D of PV is 0 because PV is constant. PV is constant or not? For this case, isothermal PV का constant होगा कि नहीं? अगर PV constant है तो dPV भी 0 हो गया. So dH क्या होगा? dH is also 0. No doubt.
Sir, how is PV constant here?
Isothermal case, temperature is constant.
हाँ,
Take example of ideal gas, PV is nRT.
अच्छा, okay,
So PV constant हो जाएगा.
got it, sir.
लिख लीजिए PV constant. So dPV is 0, dH is 0, du is 0. So delta H is 0 and delta U is 0. I hope all of you understand this first question very well. Any problem in the first part? Ideal gas undergoing isothermal expansion from 10 to 1 reversible 300 Kelvin. These are the values. कर लेंगे? अच्छा जी. अब चलते irreversible की तरफ. लिखिए irreversible isothermal. Irreversible isothermal. So when you say irreversible isothermal, delta T is 0, delta U is Q plus W, delta U is NCV delta T, which is 0. So 0 is Q plus W, Q is minus W. यहाँ तक पहुंच जाओगे. इसमें कोई मुश्किल नहीं है. पहले भी लिखा है आपने D Q is minus DW. This time writing Q is minus W, right? Is that okay? Please come to this part. Now this time I cannot write dW is minus PdV because dW cannot be minus PdV. This is irreversible. Sampriti, so what shall I write? I should write work done is equal to minus P external V final minus V initial. Note down please. Or V2 minus V1 or minus P external delta V. Okay? That is our work done. Please note down this term. And write a note there. P external may be taken as PF if no information for PF is mentioned. यानी P final ही P2 है अगर P final अलग से नहीं बताया गया. समझ रहे? P final और P2 को ही मैं P external मान सकता हूं अगर मेरे पास कोई extra information नहीं है regarding P external. Fine. So if external pressure is not specified, you can always say that P2 itself is P external or final pressure itself is P external. Is it okay? Just note down this point. So can you try to give the answer for this question? We can say W is minus PF VF minus VI. अच्छा जी. PF VF क्या होता है? NRT. PI VI is what? NRT. Isothermal case है. PF VF and PI VI will be still same because it's isothermal case. End conditions are isothermal only. Though irreversible. So VF is how much? PI VI upon VF we can substitute. Or you can also say NRT upon PF, NRT upon PI we can put and get this kind of result. So all these formulae you can derive. Is it okay? Check. I'm using PF, PV is NRT and putting the value of VF in terms of NRT upon P. Can you do that? Advik, is it clear?
So can you repeat it once more, this whole thing?
So this is clear?
Yeah.
Okay. What is V? NRT by P. So I'm writing NRT by P.
Okay.
Then next NRT by P. So this is my formula. Again, need not to mug up these formula because we can always use this one directly, no? And whatever is needed, we can use it. So these are just different results interconversions. Please note down. But as soon as you use PV's NRT, that means you are assuming which gas? Ideal gas. So those relations will be only for ideal gas. जहां भी अपने फॉर्मूले में लिखा PV's NRT वहां पे ideal gas आपने assume कर लिया. ठीक है? Any problem in this? Any issues in this? Shall we proceed? So the question here is this. Same question, but this time irreversible. And it will find the same thing. Q, W, delta U, and delta H. Try. Try to complete.
Sir, is work minus 270 R?
Good. W is minus 270 R, minus Q is minus 270 R. That is Q is 270 R. Others, please complete. So you'll use the formula minus P external V2 minus V1, put the values, and just try to solve. See, be very simple and clear in your approach. Whenever you're writing, first you understand what are the variables. लिख लो उसको एक जगह. N1 T300 है, P1 10 है, P2 is P external which is 1. So when you write these things, there is no chance of silly mistakes. Silly mistake क्या है? 1 की जगह 100 लिख दिया, 100 की जगह 1 लिख दिया, कुछ अलग आंसर आ गया. Those things will stop happening, right? And go step by step. Minus P2, V2 minus V1. V2 is nRT upon P2, nRT upon P1. nRT बाहर ले गए, P2 P2 कैंसिल हो गया. 1 minus P2 by P1. वैल्यूज रख दो, आंसर निकाल. इतना ही करना है. Easy है. Can you please complete everyone this part? Direct formula based question हो गया. कर लोगे? Can you comment about delta H and delta U now? The question is find out delta U and delta H also. How will you find? Anybody?
Sir, they will be 0 only, right?
Why delta U is 0? Because delta T is 0. And why delta H is 0?
Sir, NCP delta T?
Or we can say delta H is delta U plus delta PV. Delta PV अभी भी 0 होगा. Because
That's
PV is
isothermal.
constant. End condition PV is constant, right? Delta U is already 0. Advik, is it clear?
Yeah.
So delta U is 0, delta PV is 0. So फिर से क्या हो जाएगा? Delta H भी तो 0 हो जाएगा. Check this result. Make sense? So delta H is 0 and delta U is also 0. Next point. If you draw the graph of PV for reversible and irreversible case, reversible is this area under the curve, the whole thing, right? The green shaded zigzag portion, right? This part. ये पूरा area. What is irreversible area? Look at the formula. Irreversible was how much? P2 times V2 minus V1. Where is P2? This side. This much is irreversible. Are you okay? Magnitude wise, this is more negative, this is less negative. So we can say W irreversible is higher than W reversible with sign, of course, with sign. With modulus, reversible is higher than irreversible. I hope you understand. You solved question also 690.9 R and 270 R. Which is bigger? Magnitude wise 690.9 R, but वैसे minus 270 R. Is that fine? So remaining we'll see in the next class, that is tomorrow from here onwards. Okay, please revise this. So we have done isothermal today. Gradually we'll do adiabatic and other cases day by day. Tomorrow we'll solve some questions of JEE exam as well. Any doubt in this? Any problems, please ask. Advik,
So the
समझ
green part is irreversible, no?
green part is reversible. This ये पूरा part
ठीक है sir.
reversible. Okay, because it's PDV, no? PDV is like integral y dx.
Yeah,
Like
yeah.
Okay.
Uh-huh.
ठीक है? So let's meet tomorrow, same timing, and we'll take it forward. Bye-bye.
Thank you, sir.
Thank you, sir.
Good night.
Sir, I had a question.
Yes. Yeah.
Sir, actually, I was going through the notes of chemical equilibrium as well, and thermal equilibrium is not mentioned there anywhere.
Delta G is delta G naught plus RT ln Q.
Sir, I don't think, because Astha and Spriha also, like, we discussed on that, and neither of us had that. Like, Spriha said that it had been done, but even she had not, like, it in written down format. So maybe she done it in the previous, because I think she's already done chemical equilibrium with you once before.
Yeah. So we will do it again, don't worry. You can just write delta G is delta G naught plus RT ln Q. How to write, we'll do it. Don't worry. Okay? And you can ask your doubts also in the group, whatever you're telling. Okay?
Actually, today we have our IUPAC exams are coming, so today I was finishing up IUPAC. So I finished that mains and advanced everything.
Okay, very good.
Thank you, sir.
Okay.
Good night.
Good night.